Hi my dear students, welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. So today we are going to discuss about solutions on colligative properties, session number 3. We completed previously session number 1 and session number 2. In the session number 1 and 2 we discussed about the various types of solutions and the methods of expression, concentration terms and solubility of gases in liquids, that is Henry's law constant, and we already started vapor pressure, Raoult's law, ideal solutions and non-ideal solutions, positive deviation, negative deviation, and minimum boiling azeotrope and maximum boiling azeotrope. So, if you have any doubts regarding these topics, you just see the previous recordings, and if you have still any doubts in that, you just mention your doubts in the comment box. So, every day we are going to see these videos reviews and we will be updating all your doubts. And today we are going to discuss about colligative properties. This is the session 3 and it is going to be super awesome for your upcoming NEET examination. Those who are in grade 12 and for the droppers, this topic is definitely important and you are going to expect one question from this current class. So at the end of today's class, I can guarantee you that one question, 4 marks is in your pocket. Get ready. And hi. Deepali Patil and Yuvraj, hi. Good afternoon everybody. And let us see, before going into the deep dive into the solutions 3, we will be discussing about a few promotional slides over here. So once you are prepared for the dropping your NEET examination, Infinity Line is going to take, and it is Atreya program, and we are going to change your situation from I didn't do. So we will be changing into I will do it. So that is the confidence, and your confidence is on us. So Sri Chaitanya Academy is offering Atreya program. This Atreya program is India's most powerful NEET repeaters program, that is P square CB. And this P square CB double your preparation with physics along with chemistry and biology. You know what happened in the 2025 NEET examination? It is absolutely flop as far as the physics is concerned. Physics is a difficult subject, not only for you, for all students preparing for NEET examination. So we want to introspect into that, and we will take the difficulty level of physics on us and will make you to do physics like a pro. Definitely, you just see the link is given in the description box and you can see the details of the course, and you can enroll now. And you can do the physics is the best for you, and you're going to do the physics like a pro. And let me just quickly give you the details of the course of Atreya. Particulars, the batch commencement is started May 23. Don't worry, every week a new batch is going to be launched, so that you are going to be enrolled into a new batch. Hi Deepali and Yuvraj, those who are online, please like the session. So give me 2 minutes, I am going to take you to the exact subject that you are expecting. So you are going to see the classes from Monday to Saturday. Sunday ko chutti hai, you can write your assessments or any part test or any kind of examination. And also bachcho, each class is 1 hour 30 minutes, 90 minutes ka session hai. Hi Raj. And you can see 3 classes per day. The course is designed in such a way that you won't be getting such a pressure on you. We will be giving the subject without pressure. So 3 classes per day, 2 theory classes, 1 practice session. Aur ek baat hai, you can see classes per week, Monday to Saturday, there will be 18 classes per day, per week, and double practice class for physics. Double class for physics, so that you will be having a exact understanding on the physics. And all students, whenever you are preparing for your NEET examination, you just open the biology book and you are preparing rigorously, and also do chota mota chemistry bhi. But you are giving a less emphasis on physics. Definitely this is not good, my dear students. You just focus on physics. That decides your rank in the race of a NEET examination. And also you can see the course particulars over here. Raj, 465 classes, interactive live sessions by expert faculty. And DPPs, 240 DPPs, and this DPPs contain questions which are exactly related to your NEET examination. And also dedicated practice class, 120 hours. Faculty is going to sit along with you and make you to practice. And also after class you are going to get the revision notes at the end of the session. Definitely you need not have to write a new notes, okay. And batch size for the practice class is 20 to 25. This is very, very important. Nobody is offering this batch size in any education platform in India. Definitely. You may be sitting in 1 in hundreds, that doesn't matter, but here 20 to 25 students are sitting along with a senior faculty, expert faculty, and you will be having a direct interaction with your senior faculty, so that you will be having customized doubt resolutions in that also. Definitely this is going to be super awesome opportunity, and you just click the link that is available in the description box and you can see the course details and you can enroll in that, my dear children. And the total coverage of 11th and 12th program will be there up to the NEET level. So this program is scientifically designed by Infinity Learn by Sri Chaitanya Academy, and you can definitely win in your NEET examination. All the best. And moving ahead, India's brightest began their journey with SCORE. What is this SCORE? It is India's largest scholarship examination program. Yes, it is the program, it is intended to explore the bright talents in India. Those students who are in a grade 3 to grade 12, you can select your appropriate category and you can just click that link, and description box it is there in the link, and you can click it and you see the details. And I just want to give you a simple emphasis on this. Once you do well in the SCORE examination, you see 2.5 crore of cash rewards will be given to you. Really, it is awesome, and we want to support the students of the bright minds, want to take it out into our category, and 350 crore worth of scholarships will be given, which includes all exciting gadgets like laptops and tablets, and one more NASA trip is also planning. And also you can see up to 100% scholarships will be given if you opt for to join any course. So register now, and the link is available in the description box, and it is a very good opportunity for the students. And the examination you can write online as well as offline. You can be a student of Sri Chaitanya, you need not be a student of Sri Chaitanya, still you are able to write this examination, and examination will be conducted twice, and that is September 28th and October 12th. For September 28th examination, registration closes by September 27th, and for October 12th examination you can register up to October 11th, and you can click it and select your category, and you can enroll, and you can write the examination both in online center as well as offline center. You can sit at home and you can write the examination. And definitely it is going to be a great opportunity to grab these NASA trips, exciting gadgets, up to 100% scholarships, right? So don't miss it, and you can do the best. All the best, my dear students. And last but not least, I just want to tell you, Infinity Learn and Sri Chaitanya Academy offering NEET test series. Whenever you are preparing for any examination, you are all good students, you prepare it well. Yes, I believe it. But the thing is, how best you are doing, and what is your strength areas, and what is your improvement areas, and everything is assessed by using a test series. And for that, you will be having a NEET Infinity Learn test series by Infinity Learn by Sri Chaitanya Academy. And you can see the link is available in the description box. Still you can just click it and use YouTube 30 of coupon code, so that you will be having 30% discount on the course that is given here. And you know the speciality of this, it is based, this test series is designed in the basis of latest NTA examination pattern. So you will be having a real-time simulation for your test taking experience, so that when you really sit in your NEET examination hall, you can feel it is simply is a normal examination, so no turbulence in that. And it is created by the expert faculties from this Sri Chaitanya Academy and Infinity Land, right? So, dear students, my promotion is over. So, get ready. Please like this session and share with your friends and subscribe to NEET Infinity Land channel so that you can start the solutions part 3. So, in the solutions part 3, we have colligative properties. So, you like this animation? The colligative properties. What are colligative properties? So, the properties of certain properties of the solutions which depend on number of solute particles but not on the chemical nature of the solute are called colligative properties. They are relative lowering of vapor pressure and elevation in boiling point and depression and freezing point and osmotic pressure. Dear students, you please you find any doubts, you please use the chat box and discuss with us. And you know the important aspects as far as this colligative properties. Simple thing and depend on number of solute particles, but independent on chemical nature. This is the first important point as far as these colligative properties are concerned. And you know, the solute is supposed to be non-volatile. Solute should be non-volatile. What is the meaning of a non-volatile? The solute which can evaporate is called volatile solute. The solute which never evaporate is called non-volatile solute, like any salt. And also, all colligative properties are related to vapor pressure, mind it. All colligative properties are directly related to the vapor pressure. So, let us see the details about relative lowering of vapor pressure, elevation in boiling point, depression and freezing point, osmotic pressure. आज का सेशन में हम चर्चा करने वाले हैं जो colligative properties, and we are going to end up with want half factor, abnormal molecular mass, and start with relative lowering of vapor pressure. And you know, when a non-volatile solute and a volatile solute, what makes the difference between non-volatile solute can never be evaporated. Can evaporate. Here example is say ethyl alcohol, and you can say example sodium chloride and urea. These are the examples, right? So what happened, you know, when a less number of solvent particles are able to make up the vapor phase, so the vapor pressure will decrease. So when a non-volatile solute is added to a solution, so its vapor pressure is decreased. You can see this is the solution. It is going to have a vapors like this. These vapors are going to cause certain pressure on the surface of the liquid. That is called a vapor pressure or equilibrium vapor pressure. When you see here, this is a pure solvent. You can see these many number of vapors are there, right? When you see the solution, when you are adding a little bit of solute in this, now comparatively you can see number of vapor molecules are decreased. So this is the vapor pressure of the solution, and this is the vapor pressure of the solvent. So there is a decrease in the vapor pressure of the solution. So that is what is, there is a decrease or lowering of vapor pressure. So I just want to say P naught minus Ps is called as a lowering of vapor pressure, and relative to this, so P naught minus Ps upon relative to this is called as a relative lowering of vapor pressure. This is what is called as a relative lowering of vapor pressure. As Raoult law says it is relative lowering of vapor pressure is equal to the mole fraction of the solute, and we are going to see the definition. Solvent plus non-volatile solute B is going to give you a solution, and vapor pressure of pure solvent A is a P naught A, and non-volatile solute, it never evaporate, therefore its vapor pressure is going to be 0. So we know that Ps is equal to P naught A mole fraction of A plus P naught B mole fraction of B, and that is P naught is greater than Ps, delta P is equal to vapor pressure of the solvent minus vapor pressure of the solution. So delta P is a lowering of vapor pressure. We can say it is said that P naught minus Ps upon P naught is equal to its mole fraction of the solute. So you know Ps is equal to P naught A mole fraction of A plus P naught B mole fraction of B. You know P naught B, this value is going to be 0. That's the reason why I just want to say Ps is equal to P naught A mole fraction of A. Ps is equal to P naught A 1 minus mole fraction of B. From there you can write it. Got it? So you are going to learn this subject on a concept wise as well. Those students, you please see, to learn this kind of awesome lectures from the expert faculty from Infinity Land, simply join our YouTube channel for free of cost, and you can enjoy the lectures for free of cost. You need not have to pay anything, and take advantage of this. Please like this session, share with your friends, and subscribe to Infinity Land NEET YouTube channel, right? So, and take noteworthy points of this, and XA is said to be mole fraction of the component, it is solvent A, and XB is said to be mole fraction of the component, solvent B. And moving ahead, relative lowering of vapor pressure is given this for dilute solutions, and you can write this as a P naught minus Ps, P naught minus Ps upon P naught is equal to mole fraction of the solute, right? So how to write this solute mole fraction? It is written as number of moles of B upon number of moles of A plus number of moles of B. For a dilute solution, this can be ignored for dilute solution. So as a result of this, we can write this as a P naught minus Ps upon P naught is equal to NB by NA. If the solution is not diluted, if the solution is diluted, okay, and sometimes you can write this is the same thing it is written, right? You can calculate the mole fractions, and here you can calculate the molecular mass. P naught minus Ps upon P naught is equal to weight of the solute by molecular weight of the solute into molecular weight of the solvent, molecular weight of the solvent upon weight of the solvent. So this is the parameter can be used to calculate molecular weight of the given unknown solute. Okay, so this is going to be very important. When you do a numerical, let us use this formula P naught minus Ps upon Ps is equal to Wb by Mb into Ma by Wa. What is this? And this can be used for a dilute solution or a non-dilute solution, very dilute solution or anything. And this helps you a lot, since relative lowering of vapor pressure depends only on the solute concentration and not in nature. It is a colligative property. And relative lowering of vapor pressure, not only this relative lowering of vapor pressure, for all colligative properties I am telling you, they are used to determine the molecular weight of the solute. So I am going to give you certain important parameters here. So alternative form of the relative lowering of vapor pressure, I already shown the formula, I just want to derive this when the solution is not dilute or not mentioned. P naught minus Ps upon P naught A is equal to Na upon Nb Na plus Nb upon Nb. So it is reversed. Okay. It is P naught A upon P naught A minus Ps. Okay. So it is, you can write as 1 plus Na upon Nb, and taking Nb into the consideration. When the solute is not diluted, you can say plus 1 is taken into the other side, it comes to be minus 1. So that it is going to be Ps upon P naught A minus Ps is equal to Na by Nb. So you can write this as a P naught A minus Ps upon Ps is equal to Nb upon Na. So we can say this as Nb is equal to weight B by molecular weight of B. So you can say P naught A minus Ps upon Ps is equal to Wa upon Wb into Ma upon Wa. A is a solvent and B is a solute. Already this formula is mentioned. Dear children, this is going to be super important. When you see the NCERT textbook also, various questions has been given. Okay, these various questions can be calculated by using simply by this formula. And you can see colligative properties, we completed relative lowering of vapor pressure, bacho, and we are with elevation and boiling point is the next point. So this is already completed, right? Any doubt based on the RLVP? Any doubt? And relative lowering of vapor pressure is measured by using a Oswald-Walker method. Okay, and let us go into the elevation and boiling point, bacho, and you can see elevation in boiling point. So I just want to tell you one thing here. Water boils at 100 degrees centigrade, pure water. If you add a little bit of sugar in that, and it is going to boil maybe 105, 106. So there is an increase in the boiling point of the water when a non-volatile solute is added. So there is an increase in the boiling point is said to be elevation in boiling point. So elevation in boiling point, what is the meaning of a boiling point? The boiling point we discussed in the previous session, the temperature at which a liquid boils. So how do we know it boils? When the pressure of the vapor is equal to the atmospheric pressure, it is called as a boiling point temperature. When you see the elevation in boiling point, so these are the three different containers in which one is containing water and 1 mole of non-volatile solute and 2 mole of non-volatile solute is given. So if you check, water boils at 100 degrees and it is boiling at 100.52 degrees, it is 1.04 degrees. So as the number of moles of non-volatile solute increases, its boiling point increases. You like this? You understand? So I just want to say this is going to be a elevation in boiling point. Graphical representation better. We know the vapor pressure is directly proportional to the temperature. So if you take vapor pressure and temperature, you are going to get a exponential line, right? So the temperature at exponential line meets at 1 atm. So this is the temperature. I just want to show you, this is the pure solvent vapor pressure, that is P naught, and it is going to be Ps. Okay, and the moment the vapor pressure is equal to 1 atm, its temperature corresponds to vapor pressure, boiling point temperature of solvent, and this is going to be boiling point temperature of the solution. And ये जो दोनों के बीच में जो अंतर आता है ना, that is called elevation in boiling point, that is delta TB is equal to TB naught minus TB TBS minus TB naught. So this is what is mentioned. Look at this, and this is elevation in boiling point. Are you getting or not? Clear? And you know, this elevation in boiling point is directly proportional to the molality. M stands here, molality, and elevation in boiling point is equal to Kb into molality. Got it? Kb into molality. Are you getting or not? Now let's see, let a non-volatile solute be, added to the liquid A. Learn is a learning process, and after addition of the B, the vapor pressure of the pure solvent must decrease. So that on addition of non-volatile substance to this solution, you are going to increase the boiling point. So that is what is called as elevation in boiling point. Got it? Clear? Any doubt, bachcho? Any doubt? That's fine. Now you can see delta TB, boiling point of the pure liquid, delta TB is equal to boiling point of the solution. And the elevation in boiling point, that is called delta TB, is directly proportional to the molality, that is TBS minus TB naught. And again you can see the graph, the graphical representation. Yes, in the graphical representation you can see the vapor pressure of the solvent and the vapor pressure of the solution. The vapor pressure of the solvent will be always higher and the vapor pressure of the solution will be lower. So that the temperature, you can see the pure solvent and solution, and the temperature is 1 atm, and the temperatures which is related to 1 atm is going to be elevation in boiling point can be given between these two. Are you getting or not? So learn the graphs based on the chemistry. Physical chemistry graphs are very important, where you are going to get the graphs, more important graphs that you can see in the chemical kinetics, my dear students, and chemical equilibrium and thermodynamics and the solutions. Mind it, it is very important. Try to learn it and get a very good score on this. Okay. Now vapor pressure of the solution is less than that of pure solvent, so that boiling point is increased, and that is shown that elevation in boiling point is only depend on the nature of the number of the solute particles, but not nature of the chemical nature of the solute. Okay. So I just want to say delta TB, it is an experimentally, it is delta TB is directly proportional to M stands here molality, and it is equal to Kb into molality. Kb is called molar elevation constant. Kb is called molar elevation constant, is otherwise called as ebullioscopic constant. It is called as ebullioscopic constant and the molar elevation constant. This molar elevation constant is when delta TB is equal to Kb into molality. 1 mole of the solute is dissolved in a kg of solvent, then elevation in boiling point observed is said to be elevation constant or molar elevation constant. Okay, when molality is equal to 1, delta TB is equal to Kb. So that what happened, units of ebullioscopic constant kg, Kelvin inverse, mole inverse, very important point. Units and dimensions for this constant is very important. Definitely you can get a chance to get a question from the NEET examination, bachcho. So actually in this YouTube channel we are not going to tell all the kinds of stories, rather genuine subject will be given. Please take a pen and paper and write and get a noteworthy points. And you can say Kb is a property of the solvent, my dear students, but independent of the solute. So जब तक solvent constant है तब तक आपका Kb value भी constant होता है. So you all able to hear me? You are all able to hear me, can see me, just give me confirmation in the chat box. Those who are online, please like the session. So when you click the like session, you can see, I can see the number. So session ka josh बढ़ जाता. Okay, Dipali and Yuvraj and Raj are students, so please click it and you can see Kb thermodynamically, Kb molar elevation constant or ebullioscopic constant is equal to RTB square m by 1000 into molecular enthalpy of vaporization. Delta H is enthalpy of vaporization, and R is the gas constant, TB is the molar boiling point of the solvent, and M stands here molecular mass of the solvent. You see directly Kb is directly proportional to molecular mass, my dear students. Enthalpy of evaporation inversely proportional. Okay, Kb is directly proportional to intermolecular force, right? Abhishek, what you don't understand, it is a thermodynamic formula. Okay, in this thermodynamic formula, Kb is equal to R Tb square m upon 1000 into delta H vap. Abhishek, you can just see R is the gas constant 8.314 and Tb is the boiling point of the solvent and m is the molecular mass of the solvent and you can see enthalpy of evaporation. Thermodynamics में क्या होता है? The amount of heat required to evaporate 1 mole of the liquid at its standard conditions is known as enthalpy of evaporation. So this is all about the thermodynamic data. All quantities has to be taken in the SI quantities, right? Abhishek, fine. So as you said, delta Tb is equal to Kb is a constant into molality. We know molality and delta Tb is equal to elevation in boiling point and Kb is the constant. This constant is thermodynamically defined. Okay, so if you ask, then only we will understand. Now thanks for asking, Abhishek. Please like the session. Okay, now talking about elevation in boiling point, if it is a latent heat of evaporation is given, this is another form of the formula. That's it. Just formula is changed, right, Abhishek? And you can talk about the characteristics of Kb. It's an awesome thing. Kb is a property of the solvent and independent of the solute, right? Kb is a solvent property independent of the solute. Radhe Radhe, Deepanshu Yadav, how are you? Came late? Came late? Right, moving ahead. Characteristics of Kb, units of biblioscopic constant kg, Kelvin, mole inverse. Okay, kg, Kelvin, mole inverse. Alright. Now, elevation in boiling point, we already discussed this. And talking about the elevation in boiling point, the solvent, vapors are always in the pure solvent is more, so it is entropy of the vapor of the solvent. And you can see solution, entropy is decreased, more entropy, more randomness, right? And from here you can see it is completely converted into the thermodynamics discussions here, and we already had a discussion in the, hi Kavya. So colligative properties, we have elevation in boiling point, and relative lowering of vapor pressure. We left with depression in freezing point. We completed this and we will be discussing this depression in freezing point. Learn the things. Water freezes at 0 degrees centigrade. You add little bit of salt in that. Okay, Dipanshu. So the water is going to freeze at minus 10 degrees centigrade. So there is a decrease in the freezing point. So this is what is called as a depression in the freezing point. So that depression in the freezing point will be discussed now. Okay, all colligative properties are connected to the vapor pressure I told you. And you can see here freezing point, the temperature of, what is the freezing point? So the temperature at which liquid is going to freeze. Liquid is going to convert into a solid. So that vapor pressure of the liquid is equal to vapor pressure of the solid, which is nearly equal to 0. That temperature point is called as vapor freezing point temperature, and you can see the reason for the depression of freezing point, because the vapor pressure decreases. So it is going to be vapor pressure in the solid phase, in the liquid phase is vapor pressure 2. When the vapor pressure of 1 is equal to vapor pressure of 2, I mean to the vapor pressure of the solid is equal to vapor pressure of the liquid. There is a freezing point for acids too. Yes, of course, probe as acids are going to freeze. Okay, you know, the freezing point of this acetic acid is going to minus 16 degrees centigrade. Okay, so the moment it is comes to the room temperature, you feel as if the acetic acid is going to be boiling like anything. So this is called glacial acetic acid. You understand? Now this is a triple point and is almost about the physics you might have seen, and in the chemistry we don't actually discuss this point. Is called liquid and a gas, and liquid and its vapor. This point is called critical state, and this is what is called triple point. Okay, so let's discuss reason for the depression and freezing point. Okay, Betu, hi, how are you? You came late, why so? Beto, I am expecting you to come to the class regularly on time. Okay, you are coming regularly, please be on time. Okay, so talking about pure solvent, you see the vapor pressure and the solvent and non-volatile solute, its vapor pressure in this it is decreased, right? Whenever it is in decreased, and what we can say, vapor pressure is decreased and depression and freezing point, an addition of a non-volatile solute to the solution, the vapor pressure is decreased, and the decrease can be studied. So the freezing point of the solution becomes lower than that of pure solvent. Okay, that is explained on the basis of the graphs as well, right? So the freezing point of solution becomes lower than that of the pure solvent. You can say freezing point is reduced or decreased, or it is minimized, you can say, or suppressed. And see here it is a depression in freezing point. Tf is freezing point of the pure liquid, Tf is the freezing point of the solution, T naught F is the freezing point of the solution, pure T naught F is the freezing point of the pure solvent. Okay, and difference between these two, so Tf minus T naught F is equal to depression in the freezing point. Depression in the freezing point is directly proportional to the molality. So that depression in freezing point is equal to Kf into molality. Bas itna hi hai. But we can explore this in graphical way also. We can explore this in the graphical way also. So the depression in freezing point, it is going to be Tf and it is going to be T naught F, right? So because T naught F is the bigger value. Okay, what is Kf? That is freezing point constant, molar depression constant, or is called as a cryoscopic constant. It is said to be cryoscopic constant. Let's see in the details graphical representation. You can see pure solvent. You can see in the graphical representation, bacho, vapor pressure and the temperature. You can see the liquid solvent, and the solvent is freezing, it is coming down, and the solution, it is coming down. This point is called as the freezing point of the solvent. That is what is a freezing point of the solvent, and this is what is called as the freezing point temperature of the solution. And the difference between these two is going to be depression. Okay, Betu, you are unwell, that's why I am late. Okay, no problem. How are you doing? And please watch the recording if you are not able to attend the class, bacho. And it is said to be in the depression and freezing point, similar to the elevation and boiling point. Depression and freezing point for the dilute solution is directly proportional to molality. So delta Tf is directly proportional to the molality beta, and delta Tf is equal to Kf into mol. Betu, you tell me what is Kf? Molar depression constant. Molar depression constant. Understand? And that's what I want to say. Depression and freezing point, delta Tf is directly proportional to molality, slide wise, and it is going to be Kf into molality. What is Kf? Kf is a freezing point depression constant, otherwise is called a cryoscopic constant. Whenever molality is 1, its Kf is going to be equal to the delta Tf, right? So thermodynamically, the A water and 1 mole sugar solution, 2 mole sugar solution. Okay, and you can see here, and it is a freezing point, and you can see when you just see the temperature is said to be 100 degrees centigrade A, and a B, when you check this temperature, 1 mole sugar solution is given here. In this 1 mole sugar solution is given the freezing point minus 1.86. So there is a decrease in the freezing point. Okay, see, 2 mole sugar solution is there, and you are going to see final freezing point is going to be less than that, it is minus 3.72. So solution में जितना solute है इसका उतना कम नंबर आ रहा है. Okay, it is going to be 0, minus 1.86, minus 3.72. So more number of solutes are there, so more is going to be the depression in the freezing point. Understand? So this, Betu, you like this? You like this animation, right? Please like the session. I want you guys to see. Please hit the like button. I am very happy to see this. Okay. So आगे बढ़ना थोड़ा सा. So in the depression and freezing point, since depression freezing point is dependent only the number of the solute particles but not on the chemical nature. So what happened here? You see graphical representation, we already seen this. Okay. So you can just leave it. Cryoscopic constant is the elevation in freezing point. Depression in freezing point. When 1 mole solute is dissolved in a kg of the solvent. Okay. So this is about the Kf, and you can see characteristics of Kf, and Kf is independent on the nature of the solute but depend on किस में depend करते हैं बेतु? किस में depend करते हैं? Nature of the, it is depend on the solvent. Okay, and according to thermodynamics it is written as Kf thermodynamics, it is going to be RTF square upon 1000 into latent heat of fusion. So like this, R is a gas constant, T is equal to Tf is equal to freezing point of the solvent and latent heat of a fusion. Okay, and you can also see this applications of depression and freezing point, very very important bachcho. You are going to see very important application. Can you give me a couple of examples for the depression and freezing point? You can see it is going to be application of freezing point bachcho. It salted roads in winter to reduce the freezing point of the water. That's the reason why in cold countries the roads are sprinkled with salt. Okay, it is very important. And you can see the salt is sprinkled in the cold countries because the water freezing point decreases, so that water is going to be still in the liquid state, so that roads are going to be cleared. Okay, and also you can see application of freezing point, adding salt to the ice cream to soften it. Yes, ice cream is going to be softened by adding little bit of salt in that. So nowadays people are adding different additives to avoid the tampering the taste of this. How many of you like ice cream? How many of you like ice cream? Beto, you like ice cream? Don't eat ice cream much because the seasonal problems will be there. Okay, and also diffusion. We are into the osmosis and diffusion. What is a diffusion? Diffusion is a spontaneous flow of particles from higher concentration to lower concentration. So diffusion में particles move करते हैं, solute particles move कर सकते हैं solvent के साथ, लेकिन osmosis अलग है, सिर्फ osmosis में solvent move करते हैं, solute ना करते हैं. Okay, you can say here it is water. Okay, बच्चों, we are seeing the diffusion process of here. In the diffusion you can see when you add something to it, and you are going to see the ink is added to the water, and you can see the molecules of water is diffusing, and after some time it is going to be uniform through it. Now the color of the solution is changed. So this process, what you can say, it is a diffusion process. Understand? So hope you like this animation. Now we are entering into the osmosis beta. So a semi-permeable membrane. Before going for the osmosis, I just want to go into the semi-permeable membrane. Betu respond, what is a semi-permeable membrane? It is a special membrane which allows only solvent but not the solute through. It is called as a semi-permeable membrane. All animal membranes and you can say animal membranes, you can take an example. So here animal membrane is onion peel. These are all the examples of the semi-permeable membrane. Okay, and you can see Cu2FeCN6 is used, copper ferrocyanide is used, artificial semi-permeable membrane. Semi-permeable membrane, and this is made into a paste and layered and dried. You are going to get a sheet that acts as a semi-permeable membrane, and it is used only for the aqueous solution but not in the organic solvents. Understand? Talking about osmosis, bachcho, what is osmosis? Osmosis, the spontaneous flow of solvent particles from the solvent to solution side. Or you can see here, this is a semi-permeable membrane. I have 0.1 molar glucose and it is 0.5 molar glucose. So what happened? A solvent migrate from low concentration to high concentration. So this process is called as an osmosis. Any doubt? Right? Okay. So this is osmosis through a semi-permeable membrane, SPM. And you can see osmosis, the flow will continue till the equilibrium is attained. And what is osmotic pressure then? So osmotic pressure or osmosis pressure, and you can see when a semi-permeable membrane is taken here, you just see, and this is a solution and in that a solvent is there. So what happened? The solvent is going to migrate. This is a solution and this is a pure solvent, so that it is going to raise its height. So this is what is called the height of the column that is increased, right? So I just want to say osmotic pressure OP is said to be pi. So pi is equal to HdG. What is HdG? H is equal to height of the column and D is said to be density of the solution, and G is going to be 9.18 acceleration due to gravity. Yes, and we are into the solution. In the physics we calculate osmotic pressure pi, and I just want to say osmotic pressure, the equilibrium hydrostatic pressure developed by the solution column when it is separated from solvent by the semi-permeable membrane. Otherwise, I want to say, dear children, this is your semi-permeable membrane and you are going to get a semi-permeable membrane and it is going to be the low concentration, and it is going to be the high concentration. Carefully you see, the solvent is going to migrate from low concentration to high concentration. So, as a result of that, the solvent molecules make a collision on the surface of the semi-permeable membrane. To resist that inflow of these, the high concentration side, the opposing force is applied, that is called osmotic pressure at equilibrium, and it is going to be hydrostatic pressure. So, hydrostatic pressure is equal to osmotic pressure. So, want have said dilute solutions behave like a ideal gas, so that we can apply PV is equal to nRT. They are going to behave like an ideal gas. So, for ideal gas, this is for ideal gas. For pi V is equal to nRT, this is for dilute solution. This is for very dilute solution. So, we can say pi is equal to n by V RT, right. So, pi is equal to n by V, number of moles upon volume is going to be molarity C RT. So, this is your osmotic pressure formula. So, C is equal to molarity. C is going to be molarity. You understand? Now, let us see the details osmotic pressure. So, solution 1 and a solvent and a semi-permeable membrane, right. You tell me the direction of the movement of the solvent, movement of the direction of the osmosis. I want to know, Betu, come on, in which direction the osmosis takes place. In this case, my dear children, in this case solvent is going to migrate from this to this. This is what is called osmosis, right. Any doubt? Now, let us talk about osmotic pressure. Pi is equal to rho dZH, we already discussed, and osmotic pressure, the osmotic pressure has been found to be dependent on the concentration of the solution and the temperature. Okay, concentration of the solution and the temperature. You can see here calculation of osmotic pressure. Pi is directly proportional to the molarity, pi is directly proportional to the temperature. So, pi is equal to CRT. What is C? Molarity. R is gas constant. बच्चों R value osmosis calculate करने के लिए 0.0821 liter atmosphere mole inverse and Kelvin inverse इस्तेमाल करो. And except this, everywhere 8.314 chalta. It all depends upon the dimension that you use. Okay, and you can see on the osmotic pressure CRT and R value. I already told you, better you use 0.0821 istemal karo. And so in the osmotic pressure, it is a colligative property. Osmotic pressure, it is a colligative property. Okay, and osmotic pressure is only depend on the solute concentration and independent on the nature of the chemical nature. Okay, and osmotic pressure and a graphical representation, osmotic pressure and a concentration, it is linearly coming. Okay, and it is going to be, slope is going to give you the R value and also types of solutions based on osmotic pressure. So, various things we are discussing in the right now class that can help you a lot. So, you have types of solutions, you have 3 types of solutions, bachcho. What are these types of solution? Hypotonic solution, isotonic solution, hypertonic solution. In the isotonic solution, solution having the same osmotic, hypotonic and isotonic, or they are also said to be isoosmotic solution, pi 1 and pi 2 are the same. And hypotonic solution, pi 1 is less than pi 2, while the hypertonic solution pi 1 is greater than pi 2. So these are the three types of solutions. So when you put RBC in 0.9% sodium chloride, so the osmotic pressure of RBC is equal to, this is said to be normal saline. This is what is said to be normal saline. So it is called isoosmotic. That is the reason why normal saline is given to the body. When you take the RBC, in a concentrated solution, let us say this solution is 2.0% NaCl. So what happens? Exoosmosis takes place. Exoosmosis means osmosis taking place away from the solution is called as an exoosmosis. And cell is going to be shrinked. Cell is going to be shrinked. Okay. And I just want to take the RBC is placed in normal water. Okay, 0.1% sodium chloride. I mean to say osmotic pressure of RBC is greater than osmotic pressure of 0.1%. Here osmotic pressure of 2% sodium chloride is greater than osmotic pressure of RBC. So in this, what is the application? You can see, Betu, come on. You are going to see the endoosmosis. So this is going to be endoosmosis, and it is going to be exoosmosis. Do you claim there no osmosis takes place? Do you claim there is no isoosmosis takes place? This is what you can say, it is going to be at equilibrium. This is absolutely dynamic in nature, my dear students. It is a dynamic in nature, right? And you can see the details types of solutions already we discussed now. And reverse osmosis, this is a khatarnak one. So if the pressure applied on the solution side is more than that of osmotic pressure of the solution, then solvents start migrating from the concentrated solution to the normal solution, low concentrated solution. So this is what is called as the reverse osmosis. The condition for reverse osmosis is pressure external should be greater than osmotic pressure, my dear children. So this is what is the solvent particles move from the solution to the solvent side. This is what is said to be, you can say, I just want to say here, when you can see this is your semi-permeable membrane, this is your semi-permeable membrane, and this is a sea water, and this is a fresh water. So what I do, I am going to apply pressure, external pressure. So I just want to apply external pressure in such a way that osmotic pressure. So what happened? The solvent is going to move from the sea water to fresh water. So this is a super awesome trick that we can use to get the pure water, desalinated water from the sea water. You have in the ships we use this, and we have this purification of water system even in our domestic purpose, and we have this in the Gulf countries also. We use sea water, and the sea water, from that we are going to get the normal water, right? This is what is called a reverse osmosis. In the colligative properties, we see relative lowering of vapor pressure. We have seen elevation in boiling point, depression in freezing point, and osmotic pressure. And elevation in boiling point, we know P0 minus Ps by P0 is equal to mole fraction of the solute. And elevation in boiling point, delta Tb is equal to Kb into molality, and Kb is called molar elevation constant, and delta Tf is equal to Kf into molality. Kf is said to be depression in the freezing point constant, cryoscopic constant, and osmotic pressure pi is equal to CRT. C stands for concentration, R is a gas constant, T is a temperature. So like that we completed the colligative properties, and we have less time, limited time, so that abnormal colligative properties we are going to schedule one more session. Hope you like this session, and please like this session और एक बार लाइव बटन मारो and share with your friends and subscribe to Infinity Learn NEET YouTube channel. Okay, we are done from our side, and signing off, Suresh, Faculty of Chemistry from Infinity Learn. Okay, thank you very much, thank you.